All right, today we're going to talk about the objective function, which is the final piece in our linear programming unit. So just to recap, we started with writing a system of inequalities. Then we graphed the system of inequalities for this word problem, this application problem. By graphing, we were able to recognize where the feasible region was, that where all the solutions exist to this particular problem. And then of those, we are looking for um, the vertices, because the vertices are where we're going to get the maximum or minimum value that we're looking for. Okay, so this objective function is an equation that's used to maximize or minimize a specific number. It might be to maximize the profit of a business plan, like we'll look at here with Brantley's Bakery. So our two different learning targets today. One, we need to be able to write the objective function, okay, which is it's an equation as I just mentioned. And two, we want to be able to determine which vertex from the feasible region maximizes that objective function. Or in a case where you might want to find a lowest number, it would minimize the objective function. But for I believe all of them we're going to look at today, it's maximizing that equation. So just to recap, Brantley's Bakery, we came up with these inequalities last week. The first one was because he had 27 cups of flour to work with. The second one, he had 450 minutes to bake. And then the x is greater than or equal to 0 just means the batches of cookies can't be a negative number. And then the last one was also just saying that the number of cakes cannot be negative. So here's some new information for letter A. Brantley sets his prices so that he can earn a profit of $13.25 for each batch of cookies and $12.50 per cake. Okay, so that's not how much he charges. That's how much he is going to make in terms of a profit. So he might actually sell a batch of cookies for $20, but of that $20, he would actually earn a profit of $13.25 for each batch of cookies. So the first thing we need to do is use and write, I guess this one's already written, you'll have to write them on the others. Use this objective function to find the expected profit for each vertex. So this right here in the middle of our table is the equation that helps us maximize the profit for Brantley's Bakery. Okay, that is our objective function. It helps us reach our objective, which is like a goal. The goal being to make the most money, to have the biggest profit. So for each batch of cookies, he makes $13.25. So what we do in our equation is we take $13.25 times X, which is the batches of cookies. And then we take $12.50 times the number of cakes to get the total profit from whether it's one cake or two cakes or five cakes or whatever. And when we add that together, that gives Brantley his total profit. So when we graphed the system of inequalities last week and we found the feasible region, we noticed that all of the vertices were at 0, 0, 0, 9, 6, 0, and then 1, comma 8. At least as close as we could to 1, comma 8. The actual vertex was at 1, comma 8.333, if I remember right. But if we think about what actually makes sense here, so we can't have 0.333 of a cake. So it's not even possible for Brantley's Bakery to make one batch of cookies and 8.333 cakes. So instead we round down to what makes the most sense. He could have made one batch of cookies and 8 cakes. He has enough flour and he has enough time to do that. So I did want to just point out why that vertex was a little bit different than what you found on the day 3 homework last week. All right. Now, once we have our objective function, it's important to point out that these aren't the only combinations of cookies and cakes that he could make. I mean, he could make 2 batches of cookies and 2 cakes, 3 batches of cookies and 4 cakes, 1 batch of cookies and 5 cakes. I mean, he could make a lot of different combinations. But the reason why we focus only on the vertices here is because one of these vertices is the place where Brantley is going to be able to make the most profit. Okay, so if we are going to maximize the objective function, it's going to happen at one of these four vertices. Okay, and it will always happen at one of these four vertices. That's why we don't have to check every possible combination. We only have to check the vertices. So we're going to do that by showing our work in the table here. All right, so first off, let's use vertex 0, 0, which represents 0 batches of cookies and 0 cakes. Well, you might be already looking at this thinking, well, if he doesn't make any cookies, he doesn't make any cakes, he's going to make $0. You would be correct. But just to show our work and how we did that, we will actually, I might type this so it looks a little better. We're going to take this objective function, so 13.25 times x plus 12.5, 50, times y to give us the total profit. So we're just going to replace and say, well, x is 0 and y is 0. 0 batches of cookies and 0 cakes. And when we calculate that, of course, we'll get a total profit of $0. All right, so I'm going to go ahead and copy this to save a little bit of time. And let's change it now to our second situation where it's 0, 9 was the vertex. That means 0 batches of cookies. So I'm going to leave x as 0, but I'm going to change the y value to 9. Okay, so 9 cakes is basically what he's making. So on my calculator, I just need to figure out what is $12.50 times 9 cakes. I don't even need to use this or type in 13.25 times 0 because I know that's going to be 0. I really only need to enter the second part into my calculator. I get 112.5. Okay, now keep in mind that the 112.5 is, in terms of money, $112.50. Okay, not 0.5 cents. We don't ever write it like that. We keep going. The next combination in our vertices was 1, 8. So 1 batch of cookies and 8 cakes. So let's change that here. And we go to our calculator and we're going to figure out how much total profit that would be. So $13.25 times 1 batch of cookies plus $12.50 times 8 cakes. And that will give him a total profit of $113.25. So 113.25. And finally, our last vertex to check is at 6, 0. I need to change my numbers here. 6 batches of cookies and 0 cakes. All right, well, I know that 0 cakes is going to be a profit of $0, but I don't know how much. $13.25 times 6 batches of cookies would be, that is 79.5. So $79.50. $79.50 in total profit. Again, that's not how much it costs. That's just how much he makes above and beyond the cost of wages and supplies. That's how much his profit is. So which one of these combinations is going to help him maximize his profit? In other words, which one's the biggest number, right? Which one's the highest value? Well, $113 is higher than the $112. So the maximum profit of $113.25 would happen when he sells one, because remember that this comes from 1, 8, 1 batch of cookies and 8 cakes. So which combination of batches of cookies and cakes should Brantley bake to maximize his profit? So because this was the highest number, we want to say it's 1 batch of cookies and 8 cakes. So that's what he should do if he wants to make the most money. Anything other than that, and he's not going to make $113.25. It's going to be something less than that. All right, that is it for today. What I would like you to do is make sure that you have this copied down. So everybody has number 1 done right now on the homework for today. Again, this is Unit 5, Day 4. And then what I'd like you to do is finish the other three problems, basically doing the same process. You will have to come up with this equation on the other problems. Number 2 has a little bit of a modeling for you. You'll just have to fill the numbers into the correct blanks, but then you'll have to write that objective function. So write this profit equation for numbers 3 and 4 before you can fill out the table. All right, best of luck.